So our next chapter is graphs. Graphs here is specifically we are going to see more of kinematics here. So the graphs, what is the competence there? The competence there, the learner should plot, interprets and uses graphs to solve problems. Then we have there learning outcomes. We have 4 of them. So you should see if this graph or this activity of integration has existed at all. If it has not existed at all, then you have to do another activity of integration that should capture the learning outcome in there. Okay, so there we have hours here that town P and Q are 200 kilometers apart. At 7 a.m., a taxi left P for town Q at a steady speed of 50 kilometers per hour. So this taxi was moving at 50 kilometers per hour. So meaning, for every 1 hour, the taxi is covering 50 kilometers. That's the simple interpretation of that. So now here, they want to now first know how it moved and how it will progress. So they're telling us that after 2 hours, so it first traveled for 2 hours. So you first know where it was. So remember, it started at 7 a.m. So the time at 7 a.m. it had covered 0 distance because it was at P. Then after 1 hour, that will be now 8. It has now, for every 1 hour, it covers 250. So here I have now 50 kilometers. They told us for 2 hours. That pushes us now to 9. Then if you add for another hour, we cover 50. So if you add 50 here, we shall get our 100. So those are the 2 hours first. And told us that after 2 hours, it experienced a mechanical problem and stopped for 1.5 hours. So 1.5 hours. So meaning we add 1.5 hours here. It will be now 10:30. But remember, it is not traveling because of that mechanical problem. So the distance is not changing, but time is moving because it's an independent variable. So it doesn't change because of the mechanical problem. Then they are telling us that it changed the speed to 80 kilometers per hour towards Q. So now after this, because of the delay, he had to adjust to the speed that I can reach where he was supposed to go. So now from here means that now it changed the speed in this interval here. Now the speed is using is 80 kilometers per hour. So here up to here, it was having that speed from there up to there. Now here is changing the speed. So meaning if we add 1 hour there, now here we are covering now 80 kilometers for any 1 hour that passes. So here we have now, here we add 80, which is 180. Now it's that the distance we have to cover is 200, but we are already at 180. So meaning we have 20 kilometers to go. Now if you have 20 kilometers to go, it means that if I use this speed still 180 kilometers per hour and I add here 80, I'll be having 260. I would have passed by destination. So what do we do? Meaning we have to calculate the time we need for the 20 kilometers remaining. So what you do here, you know that time is equal to distance over speed. So now my distance remaining, remember I've covered already 180, so I'm remaining with 20 kilometers to reach town Q. So I have now 20 kilometers over the speed I'm using, which is now 80. This will give us a quarter. So a quarter hours. But now I need now to change this to minutes. So which will be now a quarter times now 60, which will give me 15 now minutes. So meaning if I add 15 minutes here, it means that it will take me 15 minutes to cover 20 kilometers if I'm using the speed of 80. So now I'm going to add 15 minutes here, so I'll be having 11:45. But in those 15 minutes, I'll cover the 20. So meaning if I add the 20 here, I'll be having the 200. So I would have reached town Q. So that's the simple logic there. Then they're telling us that after 30 minutes after the taxi's departure, a lorry left town Q. Now the lorry for it is coming from this side, but after 30 minutes. So meaning we come for the lorry. But for it, they're telling us that it left town Q for town B, traveling non-stop at a speed of 40 kilometers per hour, meaning that for it, it's never stopped. So meaning here, this one is very easy because if there is no stoppage, you can easily calculate the time. So meaning the lorry, remember the speed is covering at 40 kilometers per hour. Now we know the distance. Our distance is what? 200 kilometers, because it's the same. P to Q and the Q to P, the distance is the same, 200. Now I want to know the time this man is going to use. So time, because it's non-stop, is always distance over speed. So our distance is 200 over the speed of 40, which will be 5 hours. Okay, so now 5 hours means that it's going to take 5 hours for this man to come to reach town P if he's covering non-stop. So now, when we come to our graph now, I'm going to convert this information to the graph. I use this because it was non-stop. There was no any stoppage, no mechanical problem, no lunch, no what. Start straight away non-stop. Now, that means that now I need to first now put everything here on the graph. What am I going to start with? I'm going to now start at 7. It was 0. Now I'm going to put the information on the graph. So 7 a.m. it was 0. So 7 a.m. it was 0. Then I come at 8 and 50. So 8. Remember now my graph I'm using 2 small squares. 2 squares or 2 centimeters, 2 centimeters. Then here I also use the 2. For you have your graph, it will be very okay. So 7 there, then I come to 8. It was at 50, so 50 is somewhere there. I need a ruler. So 8, then 50, I'm going to come there, so around there. Then I come to 9, it was at 100, 9 is there, then my 100 is there, so 100 is there. Then I come, now there will solve the mechanical problem, so you see up to 1030. 10, this is 10, this is 11, so 1030 is in the middle of these two, so around there. So there we are never traveling. So still that means that we are still at 100. So still here, I'll come to my 100 there because I wasn't traveling, the taxi wasn't traveling. Then from there, we came at 1130 there, then 180. So 1130 in the middle there, then 180, which is around there. Then at 1145, so 1145 around there, it had reached our town there. So there now, I just need now to connect those points already. So you join the points. Then here we are not traveling, or we are not covering any distance. So I just need to do this, because there we are not covering any distance up to there. Then I come to this and I join it there when we reached there. Okay, so now this is now you are free to call it the taxi, you label. Then I come to the lorry, for it just uses the 5 hours, but remember it started at 7:30, so meaning 7:30 is the same. If we are in the same country, so 7:30 there, it's the same as 7:30 the other side. So this is 7 now 30. So this is 7:30 a.m. But it's going to use 5 hours. So this is going to be 1, 2, 3, 4, 5. So this is the time there. That's where now our 5 hours are. So now I join this to that. Perfect. Okay, so now this is our lorry there. Now, so they told us that the task was help the taxi driver graphically locate the point and the time where he will meet the lorry on the way. They're not telling us from what, but anyway. So the time, so this is the distance. So meaning they are meeting here, which will be 100. Then the time where they are intersecting, you just need to put your ruler there. then you go down like that. So you go down like that. So probably if I meet there, I go down like that. So that's the time. There I'm reading time. So you come and respond. So you see that you come, okay, you can take the position, you can use the reference position. So you say now here, you say, they met 100 kilometers from, you can say 100 from P, from town P at, the time was what? At 10 a.m. So meaning this man found the taxi when he's already having a mechanical problem. That's when he passed it. So that was it. For if you want to see more about these graphs, please visit the playlist. You will see more about them. That's it. Let's move to the next.